Objective. Students should be able to determine the percentage finer of different grain sizes. Intended learning outcomes. Student shall be able to determine the distribution of the coarser, larger size particles, and the hydrometer method is used to determine the distribution of the finer particles. Discussion. Sieve analysis is a fundamental laboratory test in geotechnical engineering used to evaluate the distribution of coarse-grained soil particles. By mechanically separating soil particles through a stack of sieves with progressively smaller openings, the test provides results to produce grain-size distribution curve that is essential for soil classification systems such as AASHTO. Accurate testing and minimal sample loss are critical for reliable results, as the gradation data directly relates to soil behavior under load in the presence of water. Consequently, sieve analysis plays a vital role not only in soil identification, but also in evaluating permeability, strength, and overall performance for the design of foundations, embankments, and pavements. Resources. Balance. Set of sieves. Cleaning brush. Sieve shaker. Test procedure. Write down the weight of each sieve, as well as the bottom pan to be used in the analysis. Record the weight of the given dry soil sample. Make sure that all the sieves are clean and assemble them in the ascending order of sieve numbers #4 sieve at top and #200 sieve at bottom. Place the pan below #200 sieve. Carefully pour the soil sample into the top sieve and place the cap over it. Place the sieve stack in the mechanical shaker and shake for 10 minutes. Remove the stack from the shaker and carefully weigh and record the weight of each sieve with its retained soil. In addition, remember to weigh and record the weight of the bottom pan with its retained fine soil. This table presents the weight of sieve, the weight if the soil is included, and the mass retained for each sieve number. The sum of the mass retained in kilograms is 0.502 K. This table presents the computed data needed to create a sieve analysis distribution curve. To get the percent retained of a sieve number, divide its soil retained by the total soil retained times 100. To get the percent passing of a sieve number, minus the percent retained of a sieve from 100. The sieve analysis distribution curve shows the grain size distribution of the soil sample. The curve indicates that most particles are medium to coarse sized, with increasing percent passing as grain size becomes larger. The grain size analysis test was performed to determine the distribution of soil particles using sieve analysis. The results help classify the soil and understand its ENGINE ring properties, such as permeability and strength. Overall, the experiment highlighted the importance of grain size distribution.